Very exciting. It's the start of the new academic year. This is the largest crowd we have had in person since you know when. Thank you for coming. So, and for also, we also have lots of people online watching as well. So welcome to you all, and we hope that we can see you sometime in the Varsity Theater. Tonight's program features the work of LSU School of Architecture's Dr. Tracy Burch and Department of Oceanography and Coastal Sciences, Dr. Paul Miller. They will talk about living with floods and hurricanes at a time of warmer temperatures and new climate norms. And we brought in the special effects for you all as well. It's raining outside. We want to remind you that LSU Science Cafe's goal is to continue to build a strong, informed community by providing access to reliable information, new ideas, and cutting-edge research, scholarship, and creativity from faculty, experts, and researchers in fields across the university. Tonight's event is also brought to you in partnership with local public radio station WRKF 89.3 FM. So I'd like to introduce WRKF's membership manager, Timmy Calais. Timmy?
Can I get a hey? Oh, I'm Freddie Mercury now. Okay, my name is Timmy Calais. I'm the membership manager at WRKF. I'm also the producer and the host of the Radio Drama Club, which is a new local theater program that gets broadcast on our station. This Saturday, this poster will be on the table. We are recording our first episode of season 2, Scuderia alla Scala. It's a toast to the opera, world of opera, with real opera singers, Louisiana born and bred. This is an amazing thing. They're pushing for us to go national. I hope to see you there. Come see it. At the end of this program tonight, if you're one of the lucky people to have pre-registered, your name will get pulled by Dr. Beck for this public radio nerd tumbler. You can put your favorite drink in, whether it's coffee or not, cold or hot will be great. Thank you for coming. Programs and partnerships like this are made possible because of people and listeners like you. So if you have not ever donated to WRKF, now is the time. WRKF.org, become a member today. I can't wait to have you a part of our family. Thanks for being here.
Thanks, Timmy. I'm also aware we have some special guests who have come here from the alma mater of both of my children. Glasgow Middle. Where are the kids from Glasgow Middle? Big hand. All right. Thank you all for coming, and we hope to see you at other science cafes. So now it's my opportunity to introduce today's speakers. Dr. Tracy Burch is an assistant professor in the LSU School of Architecture. She currently serves as the managing director of the LSU Coastal Sustainability Studio, a multidisciplinary research center focused on long-term stability within coastal communities. Her current research focuses broadly on developing frameworks for climate adaptation, cultural preservation, and well-being in the face of accelerated climate change. Focused on informing community development and ecological restoration policy, Dr. Burch's work seeks to examine what counts to people, not just what can be counted, and to explore the nuanced ways of valuing and dealing with change by individuals and groups. Her work takes an applied approach, working directly with diverse communities to understand how to build capacity to withstand and to recover from acute and chronic adversity. She earned her PhD in urban studies from the University of New Orleans, where her work focused on the intersection of ecosystem management and land use planning. She also holds a master's degree of urban and regional planning from UNO and a BA from Baldwin Wallace University. Dr. Paul Miller is an assistant professor of coastal meteorology in the LSU Department of Oceanography and Coastal Sciences. In addition to supervising the LSU Coastal Meteorology Lab, his current work examines hurricane-related impacts such as flooding and landscape change, as well as thunderstorm drivers in the Southeast US and Caribbean. Dr. Miller's research has documented lingering changes to heat indices precipitation, and stream flow for several months following strong hurricane landfalls. Beyond research, he also provides real-time operational forecasting support for the Coastal Emergency Risk Assessment, or SURA, Storm Surge Prediction Suite. Please welcome both Dr. Miller and Dr. Birch to LSU Science Cafe. We'll hear first from Dr. Miller.
Well, thanks for everyone for coming tonight. It's a great crowd, and I'm very excited that we were able to, that there's so much interest in kind of meteorology and atmospheric science and flooding and sustainability. Let's go ahead and go to the next slide. All right, so this is me. Thank you, Dr. Beck, for that wonderful introduction. Really, the idea tonight is that I'm going to start off. Sorry, I'm going to be turning around a lot so that I kind of see what's on screen. I know it's probably a speaking faux pas. But the idea tonight is that I want to start off by talking about the Gulf of Mexico hurricane season just by the statistics. And so the first number that I want to introduce everyone to is this number right here, 28.4%. This is the number of named storms. So when I say a named storm, I'm talking about either a tropical storm or a hurricane. Tropical depressions aren't strong enough. We don't count those. So all the statistics that I'll talk about are relating to named storms. And so 28.4% of such systems within the North Atlantic will at some point in time interact with the Gulf of Mexico. So a little over 1/4. Let's go to the next slide. And when you boil that number down, once you kind of adjust it for the number of tropical cyclones that annually occur on average in the North Atlantic, you end up with 3.7 named storms occurring each year on average in the Gulf. That can mean that they either formed in the Gulf or they formed somewhere else and then moved into the Gulf of Mexico after forming, but that generally happens a little less than 4 times a year. Next slide. However, the ones that can be a little bit more problematic that we have to think about quite carefully are these, 2.2. These are the storms that maybe you could consider a little bit more homegrown, so to speak. These are storms that actually form within the Gulf of Mexico. Again, only now referencing named storms, so a tropical storm or a hurricane. A tropical depression, we have tropical depressions that form in the Gulf as well, but they're not counted in the statistic. So these can be a little bit problematic because, maybe they form in the Gulf of Mexico and they're actually fairly close to the coastline. So maybe we don't have the full kind of maybe 72-hour warning period that we would like to make storm preparations and do evacuation plans and all that kind of stuff. So 2.2 a year. Next slide. And so that's kind of the broad picture of Gulf of Mexico hurricane activity, tropical cyclone activity. But what I also want to talk about are some of the added value that we bring in the LSU Coastal Meteorology Program. So while we can look and describe Gulf of Mexico tropical cyclones according to past statistics, we also want to provide some guidance about what an upcoming season is going to look like. And so back last year, myself and a colleague in geography and anthropology, Jill Trepanier, developed a system for predicting what the activity level of an upcoming Gulf hurricane season will look like. And so let's go to the next slide and kind of talk through that system a little bit. And so what this is, I know it's kind of really small there, it's kind of covered up by the Zoom bar, but what this is showing is the forecast developed by a seasonal weather model that's already being run by a federal agency in DC. And so starting on May 1st of each year, so that's a month before hurricane season starts, we start looking at what this weather model is saying over the Gulf of Mexico for the upcoming hurricane season. And what we're really paying attention to is the air temperature about 4 miles above our heads. What we found is that the warmer that temperature gets, generally we have a more active hurricane season. And so you'll see here, I know that the writing is small, but in this particular simulation, once it ran all the way through hurricane season, the average temperature at that altitude was predicted to be negative 6.6 degrees Celsius. Sounds cold, but remember, we're talking at a pretty high altitude. So let's go to the next slide. As anyone who's ever looked at their weather app knows, you might check it one time and it says it's going to be sunny. You check it a few hours later, it says it's going to be rainy. And so we want to look at multiple model runs. So we wait a couple days, we check this same simulation run by the same group in DC. But now, again, we're just looking at the same time period, Gulf of Mexico, same altitude. We're just interested in what the model's saying a couple days later. When we run that, we get negative 6.1 degrees Celsius. So something a little bit warmer. And what we end up doing, next slide, is we will look at this same model 16 times throughout the month of May, so that month leading up to the start of hurricane season. And once we get 16 different forecasts of the temperature at this altitude, what we then do is aggregate it into a single value, and we then compare that to the past 40 years of Gulf of Mexico tropical cyclone activity. And what we find is that, maybe let's just say for the sake of argument, that the average temperature here is -6 degrees Celsius. We go back, we look at the historical record, and we say that matches up to about, let's just say, 3 storms in the Gulf of Mexico this year. And so this is the exact data that we looked at. I'm kind of glossing over some of the detail of how this works. But basically, when we crunch these numbers, we end up with a forecast for 2022 of, next slide, 6 named storms in the Gulf of Mexico. And I would love during the Q&A to maybe circle back and talk about how that forecast is working out. And we can talk about whether or not that looks like a good number this year. Next slide. So that's kind of how, and also I'll mention too, that this is a lot different than how most groups predict a seasonal hurricane forecast. So that's another kind of great thing that we can talk about. What we've developed here is a little different than what other groups have done historically. But the other thing that we do is we want to provide guidance, and we want to kind of bring some kind of advance notice on individual storms. So we don't want to just talk about the hurricane season as a whole, but once there is a storm and it's threatening the Gulf Coast, we want to bring some value there as well. Next slide. And so what you'll see here, this is an animation of Hurricane Ida as it makes landfall along the coast of Louisiana, last year. And this is probably not an animation. Actually, I know it's not an animation that any of you saw in the news. This is actually an animation that was produced by our lab in support of a NASA field campaign that was being conducted along the coast of Louisiana. So the NASA Jet Propulsion Laboratory had brought a bunch of scientists out towards the Gulf of Mexico last year. They were conducting a lot of field work in Terrebonne Bay, which is marked here in the image. They were collecting water samples, soil samples. They had flyovers of optical instruments at the same time, all carefully coordinated. And I was the weather scientist for that campaign. Luckily, we were able to give them about a week's notice that Hurricane Ida was going to be brewing, and they were able to evacuate safely. And it turned out to be, they were able to get out just fine. And then they were able to return in September and complete their work. What you'll notice here is that in this image, this simulation was conducted the day before Ida made landfall. We actually see that the forecast landfall location is quite accurate. However, in this simulation, Ida actually skirts to the west, up near just to the west of Baton Rouge. And instead, Ida kind of jogged a little bit. It went to the right of Baton Rouge. And that was really quite fortunate for us here in Baton Rouge and very unfortunate for folks in New Orleans. So on this original track, probably everything that happened in New Orleans would have happened in Baton Rouge. But there was, about maybe 30 miles of air there that put it on the east side. And then here we see this image on the right. That's lake-borne surge barrier. One of the other things that we do is in advance of each of these storms, we help inform the storm surge forecasts that are actually produced and then given to the state in order to make decisions about whether or not to close these surge barriers. There's about 600 different floodgates across the state of Louisiana, and decisions have to be made before every storm whether or not those gates need to be shut or open. And so we have a hand in kind of informing some of the storm surge guidance that's actually handed over then to the state to make those decisions. Next slide. And then the last thing I want to mention, this is a little bit more directly flood related, since that's the topic that we're speaking about today as well. On the left right here, what we see is all these crisscrossing hurricane tracks. What these are the hypothetical hurricanes that are used in order to determine the possible range of outcomes for storm surge along the coast. So each of these lines represents a different hypothetical storm. And for each of these lines, we have there's a different storm with a different intensity, a different forward speed, a different size. Kind of all the things that affect storm surge are kind of baked into the possibilities over here at the left. And so this kind of helps us figure out what the maximum possible conceivable surge would be at any location along the coast. However, what kind of complicates this a little bit is that along the coast, the storm surge is really the name of the game when it comes to coastal flooding. That's what you're most worried about. But at the same time, the tropical cyclone is also producing a lot of rain. And while you have ocean water coming in the form of surge, you also have rain being dropped by the tropical cyclone that's trying to make its way to the coast. And you end up with a bit of a log jam. Figuring out the depth and the flooding associated with that log jam is a lot more complicated. And so what we have here on the right-hand side of the image is some work that we've done with some folks at the Water Institute of the Gulf, as well as the University of Iowa, to help inform the types of hypothetical rainfall that you might pair with some of these hypothetical storms. And so what you see here in the first column over on the right, these are just some storms that impacted Louisiana over the last couple decades. And you can see the observed rainfall. And so we looked at all those storms and we paid very close attention to how much rain it produced, how close it was to the track, how clustered was it, what sort of patterns did it exhibit, how is that related to the storm's intensity and its direction of motion and those sorts of variables. And then what we did was we created then for each storm a series of, here we only show 3, but you can make an infinite number of them, of what we call synthetic rainfall events. So these are all rainfalls that did not occur with each of those cyclones, but adhere to all of the statistical properties and all the expectations that we would associate with a tropical cyclone of that intensity, that path, and that motion. And what we can then use is extend. So what we can do is take kind of on the left, what we had was what actually happened, and we can use the fields on the right, the columns on the right, to kind of figure out what could have happened. And then we can use that to kind of figure out a little bit better what that hypothetical logjam flooding would look like. That's called compound flooding. And it's kind of a big issue when you're kind of a little bit inland and you kind of got the storm surge and the rain and you're dealing with both at the same time. So that's just a little glimpse of some of the hazards and some of the ways that we help improve kind of warning capabilities for those storms. Would love to answer any questions about that later, but for now I will go ahead and turn it over to Tracy.
Hi, everyone. Thank you, Steve, for the introduction. There we go, making sure my slide is there. I'm going to start by saying you will notice that my name and the center that I work for is actually different than what was in my introduction. So this can be our first kind of big coming out party. What is the Coastal Ecosystem Design Studio? It is an amalgam of 2 existing research centers on campus, the Coastal Sustainability Studio and the Center for Coastal Resiliency. The Coastal Sustainability Studio is who I have my affiliation with. Historically, it is a multidisciplinary applied research center focused on 3 initiatives. The first is communicating coastal challenges. So if anybody has had the chance to go to the Center for River Studies, the Interpretive Center, the lobby with the big maps on the walls, we designed those. And our job in that case is to try to convey very complex messages to the public in ways that it can be understandable by public school kids and elected officials and everyone in between. We also have this great opportunity to inspire big ideas. We get to enter into design competitions, speculative design, things like this that can really push the boundaries of what we could imagine our coast to be and what we can imagine our communities to be. And then finally, our mission is to design resilient communities. And that is really where my work comes in, and that's what I'm going to talk to you a bit about today. And just for the record, the Center for Coastal Resiliency focuses on the application of computational riverine and coastal modeling. So what we've done in creating CEDS is to bring those capacities together, to bring design and planning together with modeling in a way that we didn't have the capacity necessarily to do before. So we have the space on the dock building. We have the full first floor on the dock building, the building that sticks out into the river. So please stop by and see us at any point that you'd like to. We're going to have a big coming out party soon, so you all will be invited. So who are we? We are designers, like architects, landscape architects, planners. That is what my background is. We are engineers, both coastal and civil, natural sciences, social sciences. We work with LSU Ag. We've worked with many people in this room. So our goal is to bring all of those disciplines together to work on these complex problems. My background is in applied research. I came from 10 plus years of working directly with communities. I worked for FEMA. I worked for parishes in the state of Louisiana. I was also a contractor. I helped write recovery plans in communities impacted by disasters. And so that is how I came here to this, to LSU. And I'm really fortunate that I get to continue that work. My work here at LSU is working directly with communities to address those issues that they face on a daily, weekly, and yearly basis. So I'm not going to talk about how all communities deal with disasters. I'm just going to talk a bit about how we work with communities to help them through disasters and and the process that we see there. So while disaster declarations are not a prerequisite for working with the studio, it often happens that that's the case, right? So in South Louisiana, water and too much of it is generally a condition that we all have to deal with at some point or another. So many of the communities we work in have had disaster declarations. They've had direct impacts. They've also had indirect impacts. They are the communities that are absorbing people who are displaced by disasters, which can be equally disconcerting and kind of hard to deal with as communities. When you have an influx of population, anybody who lived here after Katrina or Ida or any number of other things know what it's like to kind of absorb populations and then try to figure out the new normal. So as a center, we are interested in the kind of sustainability and resilience of communities and problem solving. The good thing is that once a community has been impacted by a disaster, that's their mind frame too, right? They're like, how do we keep this community going? And also we got a lot of problems we have to solve. So we come at it together. I'm going to talk a little bit about the process that we use and how we engage communities of it. Oftentimes we start through what we call the Louisiana Community Resilience Institute. And we are in the process of organizing one that is working with Southwestern Louisiana communities right now. In the spring, we will be working one with communities impacted by Ida. So back to Paul's conversation. So what we do is, this is a direct partnership between the university, FEMA, and the Office of Community Development at the state. We work directly with elected officials, so mayors and parish presidents, not because they are trained planners or designers or real estate developers, but because they are the people in a community that have the most power and can make decisions that stick. They can push communities in certain directions. And the developers and other people have figured that out. And so what our goal is to help work through the issues that they face to help get them to more resilient solutions. Our prompt to them is not, we think you should do this, but what do you need to make your community more resilient? We prompt them with that, but we also ply them with governor's mansions, receptions, and free trips to Baton Rouge and professionals who address their issues. So that helps. We are in the process of organizing one of these events right now. We will have 8 mayors from across Southwest Louisiana, mayors and parish presidents who will come and stay with us. We will pair them with professionals, architects, landscape architects, floodplain managers, real estate developers, all kinds of people. The mayors have projects that they come to the table with, the thing that they think they need. We have myself, we have other staff. We also have graduate assistants who work with us directly to help develop these projects. The mayors come here to Baton Rouge, they pitch their project, everybody workshops it for a couple of hours. They find out that they need a lot more than what they think they did when they started. But they also have a path forward and how they might get there. Then they pitch that same project again to resource people. And sometimes those resources are agencies. The EPA has a program. The Office of Community Development has a program. Sometimes it's nonprofits that can help. And sometimes those resources are at LSU. And so we have worked in various capacities. We've worked with Clint Wilson and his civil engineering students. We worked with Corey Consauer and his students, a postdoc student, to do hydrologic modeling. The other thing we can do is we can center studio courses around this work. And so anybody who's not an architect or a landscape architect might not know what a studio course is, but all of our design students spend a semester working on a problem, really. And so oftentimes what we do is try to pair a community's problem with students who can do deep dives and really think outside the box. So I'm going to show a couple props real quick. So these are each examples of books produced after a semester working on an issue. 2 of these are related to sand and gravel mining in the Amite River Basin, which is a big issue when you think about capacity and stormwater management. So we had students who spent a whole semester working on this. This is about flood control and urban agriculture in North Baton Rouge. Again, this was a project where we had students that spent an entire semester from both architecture and landscape architecture. We also created, through support from the National Endowment for the Arts, a master plan for the Baton Rouge farm that gets them closer to being able to kind of build out the farm that they imagine in the future. So in that case, we're really thinking about education, but we're also looking at how we can engage research and funding to further projects along. Okay, so this is the mayor's workshop. We have these opportunities both to kind of work directly with them, to bring that information back to the university and try and use university resources to get us where we need to go. We are affiliated with the university. We are not actually in a department. Our goal is always about education, but it is of course about research. The studio is a research center. Over the years, we have had numerous ways that we get to that. We currently have a large grant working with the Corps of Engineers and the Department of Defense, looking at issues around designing with nature. And this last summer, we had an internship program where we had 16 interns from across the Southeast United States come to work with us. So if there's anybody here who's a grad assistant or grad student and interested in coming to work with us for the summer, check me afterwards. But we also work directly with grad students. Like I said, the Mayor's Institute engages grad students. Over the years, we have educated more than 150, and over the years is since 2009, 150 graduate assistants have come through our program. And in particular, we had a project, Clint Wilson is here and was a PI with me on this, with this grant called Inland from the Coast. This was a process where we worked directly with mayors on the ground. In particular, I'm going to come back to Baker because this is the example that I think can kind of get us through there. We had 37 graduate students who worked with us over 4 years on this project. I'm going to have Holly go ahead and advance the slide real quick. This project started with the realization in 2016 that the state of Louisiana was pushing people away from the coast and saying move inland because it's safer there. And 2016 showed us that it wasn't necessarily safer there, that most of the places we thought of as safe were in fact not safe and had flooded. So these are just some of the pre-research that we did as a studio, looking at who was impacted. We also recognized that about 90% of the people who were flooded had no flood insurance, which was a huge problem as far as recovery is concerned. Next slide. We did studies looking at why this would be the case and what would the dollar figures look like, recognizing over time that housing has changed. What we found was lots got smaller, houses got bigger, and for the most part, we were building them in floodplains now versus historically where we had not built in floodplains because we recognized those were areas that flooded. Go ahead. And finally, this was not a problem that we didn't recognize. This is the quote from the Harlan-Bartholomew Plan from 1948 in Baton Rouge. It goes on to say that inadequate amounts of infrastructure and poorly maintained infrastructure were an issue and that we should be building in stormwater management into our community. The maps on the bottom, you can see kind of how that follows through. This was the map in the proposed greenway area or waterway areas. The center is the FEMA flood maps and flood depths. And then on the left, you can see that what we've actually built is a system that has no capacity in it to store water. Next slide. So with this recognition, we went to the National Academy of Sciences. We asked them for some money and they gave, lo and behold, they gave it to us. And so what we did is work directly with communities in need. And we engaged 13 PIs from across the university and multiple universities, as well as creating professional partnerships with the American Institute of Architects, the American Society of Landscape Architects, the American Planning Association. And for 4 years, we worked together to try and understand how we could improve conditions for communities on the ground. We held public meetings, we created strategies for these communities, all with the goal of giving them a product. Show you this, a product at the end that would provide them a roadmap, but that they could literally cut and paste and put into a grant application so that they could start requesting funds to actually implement projects. So Baker is one in particular. Baker has a soft spot in my heart, so they're getting the preview today. So we held public meetings, click it, that engaged professors, that engaged students, that engaged community members, all kinds of work to try and understand what was important to people in their community and how we could preserve that while reducing their risk. Next slide. So we also looked at key spots within the community that could be upgraded. So this is Baker Park. This is one of the primary parks within the middle of the city of Baker. Click at the slide. We created a series of plans, not just graphics, but also policy steps, definitions, strategies to get there, phasing. And so there's 5 of these. So I'm going to let you just kind of go ahead and go through them. So this is Brushy Bayou, one of the main drainage canals in the city. How could it become an area that also creates park space for the community? Next slide. Broom Road, this is the library. This is publicly owned property. It's right next to City Hall, so it's already publicly owned. It provides an opportunity for communities to, for the community to do projects where they don't have to be acquiring property, and it could reduce the cost for them. Next one. Okay, next one. This was the issue that the mayor came to the workshop with. We have subdivisions, they're already built out, we're getting water in them. How do we reduce the amount of water that gets in people's houses? Not from the 2016s, but from the normal rains. Next slide. And last, we provided them, do one more slide. With a strategy for implementation, how do you start to think about this when you're doing your policies, your zoning ordinances, your subdivision regulations? So click it. That is how we try to work with communities on the ground, to help walk them through the process, to give them the capacity. I should say all of these graphics were done by graduate assistants that worked for us, who have all gone off to work in the communities that they had a chance to work with on the ground. So our goal, of course, is to create the next generation of design professionals who can address the issues for communities on the ground and think through multiple lenses. Architects thinking about landscape architecture and floodplain management and planning. That's really our goal with this. And the final slide is that we had the opportunity to take this information then to a much larger group with the prompt. And when I say larger group, these were folks from the state, these were design professionals, these were researchers, and we said, how would you design a watershed? The state of Louisiana is moving towards watershed management. We said, design the watershed. We gave them some prompts, some scenarios, and what we really did was come away with 4 different scenarios that start to break this thing up by its ecosystem boundaries rather than its political boundaries, its kind of uses, and how do we start that conversation moving forward? And we've been fortunate enough to work with people like Tom and others to really continue that work into the future as well. So I'm happy to answer any questions about this work. I'm happy to answer any questions about the work that we do. I think is it time for us to, yes, okay. And with that,
Yeah, looks like we have our first question.
I will repeat the question. The question was, based on this slide that's right behind me, do we work with the Watershed Initiative? I would say yes. Do we work with them with this map specifically? Probably no. What we did as an exercise, when we kind of went through this, we wrote a grant before there was a Watershed Initiative. And so we engaged them in this process, but what we wanted to know was both how might communities break the watershed down, how might you think about it, but really where were the opportunities? What are the things that elected officials, agencies, communities, and nonprofits, et cetera, could coalesce around? And so that was really what we took away from that. And so in a lot of ways, that's the work that we're trying to push forward. But we work directly, again, with Tom Douthit, who's right next to you, Rachel Sanderson, who works for the Capital Regional Planning Commission, and having the opportunity to really figure out what it means to plan and design a watershed, or flying the plane while we're building it kind of thing. So yes, we do.
Any preference for the order? Okay. Yeah. So the question was that there were two questions there. I'm going to tackle the second of those, but it was basically a coupled question where the first was we're talking about how we get rid of water when we have too much of it, but also we now see that we also, for instance, over in Europe and the Western U.S., where we're having extreme droughts. So maybe is there some possibility where we maybe think about storing some of that water for periods when we really wish we had it, and then what does maybe what do those outcomes look like in Louisiana as far as drought and extreme flooding? Yeah. So yeah, that's a great question. Certainly, we don't have to go far to see areas of drought in the U.S. Also, Europe's dealing with some extreme circumstances as well. Actually, even up through early summer, there was a large portion of Louisiana that was actually in relatively severe drought. Not nearly the level that they have out west, but if you remember, kind of especially May, the first part of June was really dry. We really baked the landscape, and probably the amount of moisture that we've had the last few months probably didn't seem likely if you remember if someone had told you about that in early June. So yeah, when we look into kind of future extremes. So when temperatures get warmer, we have something we call the Clausius-Clapeyron relationship. Now that basically means that the warmer that the air gets, its capacity to hold water vapor increases. And what that kind of the natural extension of that is that the more water vapor in the atmosphere, that your higher kind of extreme precipitation events where you have 4 inches of rain coming in an hour and a half, the chances of those events perhaps goes up. Now, the flip side of that is droughts as well. Now, droughts are due to kind of larger scale circulation patterns. The projections that I kind of look at for Louisiana are a bit of a mixed bag as far as what the mean precipitation change is for Louisiana. There doesn't really seem to be a strong trend towards drought, particularly in those projections, but certainly kind of those high-end extremes, those short-term rainfall events where you end up with a bunch of water, you need to figure out what to do with it really quickly. Those are kind of the events that we have to worry about a little bit, kind of keep our eye on moving forward. Yeah. Go ahead. I think.
And I'll just say that for the most part, all of the work we're doing now is related to storing water within the landscape. So communities, there isn't enough money or enough space to dig a deeper ditch or a ditch big enough to be able to convey all the water that needs to be moved. And then you compound that with more development happening within an urban area. So much of what we're looking at is how do you store the water in place? How do you hang on to it as long as possible? And then the hope is, of course, that you're storing water, but also that space in the 90% of the time when it doesn't need to store water is enhancing your community, right? So those graphics show that, right? It's like, but there are also bike paths, there are bioswales, there are parks, there are all these things that kind of center around that, where you increase your capacity, but you increase your assets as well. I think it depends on which river. Right. So multiple questions. The first is part of our goal more parks and less concrete? I think the simple answer is it's not necessarily making new parks, but it's better utilizing the ones you have, because oftentimes they are lands where the water flows anyway. That's why they're parks. They fill up with water, but you can engineer them in a way that stores more water to make them more useful places, and then removing concrete so that it's not sheeting off, that we find ways to do that. The other question is, what do we do about kind of backwater flooding or upland flooding? That is part of the question of designing the watershed. The last slide that you saw really looked at things, strategies, and we're not there yet. We're trying to understand what that means, because just building a retention pond or a detention pond is not going to be enough upland. So there's a full system where it's trying to understand what that means. Part of it is just building a bigger conveyance canal doesn't eliminate risk. So you need the combination. There's a way of moving water around, there's a way of increasing capacity, and there's a way of recognizing your risk over time that has to happen. So
about let's go back in the corner and then maybe we can do Kathy. I know, yeah. Kathy's had her hand up. I'm sorry.
So one of the question is how would more parks um, fix the problem associated with 2016 and also the fact that they're building the Baker Diversion Canal or it's Baker Diversion Canal, and how will that will help. Baker's actually in two separate watersheds, so it's going to help with some of the development, and on the other half of the city, it's not going to help because that water flows in a different direction. It's not going to make it in that canal. So that's an issue. It's really looking at the watersheds and the subwatersheds, and that canal will still reach a capacity, and the more development that happens upstream is going to push more water in. And so there's still a need to improve storage capacity in the place, right? And so our goal is to try to not tax the systems as much. How can we think holistically about having these canals, but also having parks that can store water? And you just mentioned the Netherlands example. They've moved to a model where all parks can absorb water when it rains, right? And so this idea that you can reduce the load on the system in a way that also benefits the community is kind of the direction we're moving.
Yep, Kathy. Yeah, so that yeah, this one's a little sticky. So the question was during my slide deck a little earlier, I showed kind of this new method that myself and a colleague, Jill Trepanier in geography and anthropology, had introduced that would produce a Gulf of Mexico hurricane season forecast. So produce some sort of expectation about how many named storms we could expect to see during the upcoming hurricane season in the Gulf of Mexico. I mentioned that was a different system, that the way that we're doing that is different than how some groups are doing it. So I think there's one question that is exactly how is it different? And then the other question is, we said it yielded 6 storms for this year. How are we feeling about that? How's it looking out? Yeah. Okay. All right. So the first, the answer to the first part of that is that ours is really simple. It's really straightforward. We're looking at one variable, air temperature, at an altitude of about 4 kilometers. In meteorology, we actually measure altitude based on pressure, not on geometric height. So we're technically looking at something we call the 500 millibar height, but I'm kind of getting into the weeds a little bit. When you look at other groups, the way that ours is different is that it's just focused on the Gulf of Mexico. We aren't interested in the rest of the Atlantic. And so historically, any sort of hurricane season forecast, kind of invariably, you'll see a news story each spring that says, that NOAA's calling for an above average season this year, or there's groups at Colorado State that do this as well. They're talking about the whole Atlantic. So in our view, there's this void of like, well, what does that mean for the Gulf of Mexico? Off in the Atlantic, you can have a tropical cyclone that we fondly refer to these as fish storms, that they just kind of spin around in the broader Atlantic and they don't really do anything, at least from a human impact perspective. As we know, once a storm gets into the Gulf, guess what? It's probably going to hit land somewhere. So we felt that was a void where we could add some value. Our system's a lot simpler than the others. They'll look at multiple variables. They'll look at El Nino, La Nina. They'll look at wind anomalies over a certain area of the globe. They'll kind of aggregate all those different factors together in order to produce a single North Atlantic forecast. One of the things I think is really cool about our system is that whatever our forecast is, what I've just noticed is that if you take, so I said earlier that 28.4% of storms in the North Atlantic impact the Gulf of Mexico. If you take our forecast and you multiply it by 4, basically, you actually get a really close number to what the people forecasting for the whole North Atlantic get. And so I think it shows that even if you're looking just at the Gulf of Mexico, it's telling you something about the rest of the Atlantic as well. The other question is, how are we feeling about 6 storms? Anyone know how many storms we've had in the Gulf of Mexico yet this year? Yeah, that's a big goose egg. So we haven't had any storms in the Gulf of Mexico yet. I think, yeah, which is a great thing. I would be thrilled to be wrong about this. So I would view that as a great honor to be off by 6 storms. Unfortunately, when we look at the data, I think we still are looking at an above average season. Ultimately, all we have to fall back on are the same data that we're looking at. Even if you look at some of the other indicators, things like the Madden-Julian oscillation, that describes kind of some locations of thunderstorm activity in the Pacific that's useful for forecasting, that indicates above average. So we can, there's a tendency to want to hit the panic button and maybe say, oh, we were probably wrong, but we'll wait until the end of the season, and things look like they're going to pick up here over the next few months, unfortunately. Yeah, so that's a really good question. So the question is, I said that what we did was we looked at that temperature, that 4-mile altitude, and then we compared that to hurricane activity over the past 40 years. The question is, well, when we're looking at next year, is next year going to be indicative of what the last or maybe a better way to put it is, were the last 40 years indicative of the years that we're using to forecast ahead of us? Maybe is the question. And so the answer is, yeah, that's a little, that's a little challenging. Obviously, when you're looking at a new year, and if you're setting a new extreme, that's a record that you haven't been able to calibrate against. One of the things that we really prioritized when we developed this framework was that we wanted it to be very, very simple so that we could easily recalibrate it moving forward. The more sophisticated and the more complex some of these forecasts get, it makes it really hard to kind of go back and figure out if kind of the old relationship is still valid. The atmospheric science literature, or which is kind of our academic term for the papers that people wrote about this stuff, is kind of littered with proposed forecasting systems that just kind of died, that no one ever went back and actually calculated on a year-to-year basis or improved. So let's say that maybe this year turns out to be a little bit of a down year. Maybe it's closer to an average year instead of an above average year. It probably needs to be recalibrated into our model as a result of this. And so that was something that we placed a very high value on. And I think it's a key kind of strength of what we developed. So hopefully we can go back and reassess those and constantly improve them so that they're just as good for the next year as they were for the last 40.
Looks very different. This work that I described, for the most part, is working with communities that are within a hurricane protection levee. If only because there are not a lot of incorporated areas outside of the hurricane protection levee. We are getting ready to work with southwestern Louisiana communities who are impacted by Laura and Delta, and they don't have hurricane protection levees. So it's very different circumstances. My personal research works in many communities that are outside, but that's outside of what we talked about today. So we have 1, 2, 3, and then I think, so this lady right over here. Okay, we're gonna go with Paul first.
Mm-hmm. Yeah, you have a very wise neighbor. I'll say that. So the question is, so we have an attendee here. What's your name? Joy. So Joy has a neighbor, and so Joy was talking to her neighbor, expressed that she was experiencing some allergies earlier in the summer, and her neighbor said, "Oh, it's all that Saharan dust." And by the way, that Saharan dust is also one of the reasons we haven't had any hurricanes yet. And so there's a lot of validity to that. To answer your question, no, that is not something that is incorporated into our model. Now, I do actually, even though I'm kind of up here talking about hurricanes, I actually do a lot of work with Saharan dust in the tropics. But actually, when I do work with Saharan dust in the tropics, I'm worried about drought. That's actually why we look at drought dust in the tropics, because dust can kind of, in general, since it's all air that not only has dust in it, but that means it came from the Sahara Desert, so it's really hot and it's really dry. And it's really hard for thunderstorms, which you need thunderstorms to have a hurricane, to form within these very dry, hot, kind of dusty air layers. It really can kind of shut things down. Now, if that dry air is forecast by the model to make it into the Gulf of Mexico, then we could pick that up in the temperature signal. Since I said that pocket of air is really warm, and we're looking at the air temperature about 4 miles above our heads, if our seasonal forecast model that we're consulting is up on some Saharan air, making it into the Gulf, then that is something we could look at. But it would be kind of implied. It's not something that we directly consider. Does that answer your question? But yeah, that was certainly for the month of July. July was a very dusty month over the Atlantic. And that really kind of shut off any sort of hurricane activity, at least for July. Dust generally wanes into August and September, October. That's one of the reasons that peak hurricane season is a little bit later in the summer, because climatologically, that's when the dust starts to die down. Mm-hmm. Yeah.
Yes. The question is, when we build subdivisions, then we take out trees, we add more concrete, and we build detention ponds that may or may not work for a long period of time. These are all issues. Is there an effort to build more trees? Yes, but I don't know what the scale is right now. Or that is part of what we kind of work towards. And that the fact that parks are, the way you think about parks should be a little bit different. It's not just a place where you can play ball, but it is also a place that has wooded areas, and those should be low wooded areas because they can absorb water. And so you have active and passive recreation and just different ways of thinking about how we've done parks. And we talk about parks in a lot of ways now, it's just land that was never developed. We are really talking about how to engineer them in a way so that they can absorb water. So it's not just leaving them as they are, but actually kind of moving earth around, planting trees, putting amenities in, but like thinking about the storage capacity in ways that we haven't always done. Okay, right here. Yeah. Are there specific trees to absorb more floodwater? Absolutely. A cypress tree can hold 800 gallons of water, and a live oak tree can hold even more than that. So the bigger the trunk, the more you want to plant that tree because it will absorb water, and lots of it. So yes. Breck has been invited. They are a partner of ours. They actually have worked directly with us when we work with classes and specifically on sites. The School of Architecture last spring held an all-school workshop where we had students work through how to increase stormwater capacity within parks, and Breck was the main partner. So yes, the answer is yes. And they have been very proactive in coming to the table to think how to absorb stormwater, because there's not a lot of space in Baton Rouge. So the parks become the obvious place, and they're really forward thinking about this and how do they interact with the watershed initiative and other things like that to make this happen. So
I've been notified that this gentleman will be our last question of the evening.
Yeah, this is a great question. So data visualization is important because that's really how, and to a large extent, how we communicate what we think is going to happen. And so if your data visualization is unclear, then sometimes, unfortunately, people maybe get the wrong message. And so one thing, so just in particular, I know that there's a lot of conversation. So, there's one piece of this, which is how does the public visualize something like storm surge, maybe? So, a lot of times when we're forecasting surge, or when I help the people who do that, they're looking at maybe the height above like a certain kind of geodetic surface. But really someone wants, and basically when I mean that basically is a kind of a theoretical like sea level kind of mean zero point. But really someone might more be concerned with, I'm standing on ground, how deep is the water going to get right here? And so kind of bridging the gap between maybe how we kind of represent inundation in a model, and then kind of how someone's going to interpret that and make a decision of if I need to evacuate or not, can be really important. And sometimes there's a mismatch between the resolution of the model and kind of the resolution of the land surface that we're putting it on. So it can be kind of challenging. From a disaster management perspective, you actually want to have a lot more data on that map than just the inundation potential. And so, for instance, if you're the National Guard and you want to figure out where to station assets and how to move them around, if you want to know where to put an evacuation center and you want to make sure that it's in an area that's going to be safe from the storm, if you want to visualize when you first expect the tropical storm force winds to reach that location, then you need to have that on the map. So there's lots and lots of different layers. It's actually, there's so much relevant data in advance of a tropical cyclone making landfall that's actually hard to fit it all on one map. And I would say that that's kind of some of the biggest challenges that we run into. And then on top of all that, indicating the uncertainty in that map as well. So we think that the tropical storm force winds will arrive in 12 hours, but it could be anywhere between 8 and 14. And so how do you communicate that in a way that people can
then used to make accurate and well-informed decisions. It's a very interesting problem and challenging.
Thank you. Let's give a warm round of applause to Dr. Birch and Dr. Miller. Thank you for for a great presentation. So before we wrap up, I have 3 announcements. One is very important. This is not it. No, it is. This is important too. We have a special announcement that we're announcing today. In January 2023, LSU Science Cafe will be celebrating its 10th anniversary. Oh, come on, 10 years. We are so excited about this, and we invite you all to join us on Tuesday, January 31st, for an absolutely fabulous evening. We're going to do some special things. It's going to be a little bit longer, a little bit bigger, a little bit bolder. We want you here. So please, please, please save the date. We want to see you on Tuesday, January 31st. We'll have more information on the guest speaker. We know who it is, but we just can't tell you right now. We will soon. The next is next month, our LSU Science Cafe will be on Tuesday, September 27th, with the executive director of LSU Leadership Development Institute, Dr. Leslie Blanchard, and she's going to talk about how to lead like Joe Burrow. This is going to be a great talk. And then finally, this, oh, come on, this goes to Madeline Kelly. Where are you? Up. Okay. Stay there. We'll get someone to get it up to you. Thank you all so much for coming. This has been you've been a great crowd. This has been a great show tonight. Thank you so much. We'll see you next month.